We're doing a lesson on composite functions, all right? And it almost brings in like heaps of things that we've done already in this course. So we're going to be substituting in for f of x, which we should be able to do, and domain and range. So pretty much we're just combining them, and that's what happens in this course. It starts combining a lot of little things. So let's get straight into it. Okay, so composite functions. So what we're going to do is the first example will be something that we know. Okay, so if I've got f of x equals x squared minus 1, what's f of 2x? Well, all I have to do is substitute this in for x. So I'm going to do that right here. F of 2x is equal to bracket 2x squared minus 1. And then because I'm squaring, because there's a squared right there, I have to square both the terms, so the 2 and the x. So it's going to be 4x squared minus 1. And that's all that it is. Okay. Now, this is where we're going to do the composite functions. If g of x equals 1 plus 3x and h of x equals x minus 1, what is g, and we're going to substitute in h of x. So what we have to do is that in here, we're going to substitute this whole thing. So let me write it out. So it's be g, and then h of x will be, I'm going to write out g, 1 plus 3, and I'm going to substitute everything that's h of x. So it'd be x minus 1. And then I just go in, 1 plus, and then I ski jump it. 3x minus 3. Now I can combine like terms. So that's going to be 3x, and I think it's negative 2. Okay, so therefore g of, and I'm going to close that bracket, h of x equals that. So essentially we're doing the same skill, except now we're substituting a whole function into another function instead of just a number or something like that. All right, let's look at the second part of this, and that's the domain and range part. Let's find the domain of this one, f of x. Well, I know that in the real domain, we can't have negative numbers underneath it, but we can have 0. So I'm going to do, I'm going to go f of x equals square root of negative 1. So I can go for domain, x minus 1 is greater than or equal to 0, because it has to be positive. It can be 0. So we just solve for it. Therefore, it equals 1. Okay, so the domain is that for real values, where x belongs to the real values. Okay, and the domain range will be applying, but in these examples we're not going to look at range. For g of x, which equals 1 over x, x can't be equal to 0. So x is not equal to 0 where x belongs to the real number plane. Okay, so we know the domain of both these things, but we know that we can't have x equals 0 at the bottom of the fraction, because the Cookie Monster gets upset. Actually, we'll break maths if we do that. So really, really important that we don't do that. So there's a second question here, and I've got to put a bracket there. What would the domain range be of g of f of x? Well, g is this, all right? So that's g of x. And if we substitute in f of x, we have to substitute this whole thing. I might use a different color. We have to substitute that whole thing. So let's write out what g of f of x equals. G of f of x will equal 1 over this whole thing, square root of x minus 1. Now, we probably have seen this, and we can clearly see that the domain is a combination of both this one and this one. So we can say that x has to be greater than, but not equal to 0, can't be equal to 0 like this one. okay, because we're at the bottom of the fraction now, greater than 1, where x belongs to the real number plane. Now it's really important that we understand that. So we know that. Let me try explain it one more time before I go. So this bit under here can't be 0 because it's in a fraction. We can't have the denominator 0. And also the same rules that applied for this one apply. So that's why that's the answer. So there's only one little thing difference between here and here. If you don't get it, please ask questions. Anyway, that's the end of this lesson. Peace out.